All right, guys, good morning. My name is Krishna, and I will be covering some few aspects of optimizations. Okay, mainly loop optimizations today, and time permitting, tomorrow we will talk about optimizing parallel programs. Okay, சார் வால்யூம் ரொம்ப அதிகம் தான் இருக்கு. கொஞ்சம் கெயின் கம்மி பண்ண முடியும்? Yeah, good. See, different people have different idiosyncrasies. Okay, everyone has some craziness. I too have some craziness, and my craziness requires that the class when I teach should be quiet when they are listening, to participate as much as possible. Okay, I want each one of you, okay, no exceptions. So I'll be teaching today and tomorrow. Each one of you make it a point that you will ask at least 5 questions. You will answer at least 5 questions. Okay, more the merrier. It's perfectly okay if I don't cross beyond slide 1. My goal is not to teach a lot of things. My goal is to make sure whatever we learn it well. Okay, don't hesitate to ask why. I will say, for example, this is better. Why? Till the time you are convinced, let the vehicle not proceed. Okay, each one of you have a brake. Each one of you have a brake. Use it extensively. But the brake be talk to me, not discuss among yourselves. I forgot. This device, let me put it on mute. I hope you have also done the same. Okay. Yeah. Any questions before we start on how we proceed? All of you are familiar with C code. We'll be spending most of our examples studying C code. Okay. We'll talk about loop optimization, but before we do, I'll maybe just to make sure that we are in the same continuity, we will start with bit of background and then go to loop optimization. Okay. Hello. Are you awake? Oh no, it's not awake. Now it should be awake. Yes. As I said, my name is Krishna, and if you are interested to write to me, that's my email ID. Okay. We will have 2 main goals for us. One is introduction, second is loop optimization. Okay. Some of these slides, by the way, are taken from Tony Hosking from Purdue. He was at Purdue, now he's not, but yeah. And some are also taken from Milland at Purdue. Okay, fine. We are studying compilers, right? I thought all of you should get some kind of real pleasure and pride in choosing compilers. It's probably one of the only subjects where you will find a mix of everything that you study in the rest of CS. I kept AI ML on the top because that's kind of probably the hard thing, right? Pick AI, pick algorithms, pick theory, pick systems, any systems courses, architecture, you study about optimizations, you study about networking, you study about databases, pick anything of your choice, right? You will see 2 things. The techniques you learn in those subjects are applicable in compilers, are useful in compilers. They can impact compilers, and compilers can impact them. It's probably one of the true sangams that you can really see of CS courses. Okay, Pick any subject of your choice, right? That, and you are kind of comfortable in it. You'll see, you can ask, hey, you know what? I really like subject X. I want to apply X in compilers. Yes, there is. You will find. Oh, sure, absolutely. Actually, you know what? I will take it away. Thank you. मैं भूल ही गया था कि I kept my bag there. Right? So it's a good mix of theory and practice that you will also see in these 2 weeks, that many of us will be talking about applying this algorithm on these examples, right? Changing this code to get some performance, right? Things like that. Okay. So you would have seen that we started our classes by saying, look, a compiler generates some machine code, let's say. You have a front end. The front end generates IR, intermediate representation, it is given to the back end, and the back end generates machine code, right? And front end and back end both can generate errors, correct? What type of errors we are talking about? Can you give me some examples of errors? Say syntax errors. Syntax errors are given by which pass? Front end, back end? Front end, okay. Give me an example of a syntax error. Semicolon missing, okay. Which is given by the parser, right? What about the scanner? Can the scanner give an error? Invalid tokens. Can you give an example of an invalid token? Let's say we are talking about C code. Sorry, what did you say? Let's say I have a simple keyboard, okay? So I have written a program and I want a lexical error. What can be an example of a lexical error? Give me the name. Give me an example program that will be considered as an error. One at a time. Yeah. 1, 2, 3 equal to ABC. All of you can see it, or something is blocking you? Okay, 1, 2, 3 equal to ABC. Let's say we are talking about C code, right? Is it? It's clearly erroneous. All of us see that. But where did the error come from? In the syntax analysis or lexical analysis, or the question is, I want an error in lexical analyzer. Which part of it is a lexical error? So what will the lexical analyzer do? It will mark this as a token, this is another token, this is another token, and this is another token. So I have 4 tokens, no lexical error. Yeah. You have your keyboard in front of you. Tell me what you will type. And by the way, I would encourage you guys, if possible, close your laptops, take out your notebooks and write. Because what I'm afraid, sometimes we get distracted easily in laptops. And then the distraction spreads. Okay? Yeah. Tell me, give me a code. I'm a machine. Yeah. Give me a code. Let's say simple keyboard, like what you have on your laptop. Your laptop, does it have a rupee symbol? No. I mean, we happily accepted that lexical analyzer can give errors, right? I don't like it. I want to see, whenever I make a statement, whenever you accept a statement, convince yourself that you agree, right? I mean, I'll tell you, you will be earning $1 billion a month in future. You will agree. You won't argue much. If I tell you, no, you will be giving me $1 billion a month, you won't agree, right? Similarly, I mean, think before you agree or disagree. So lexical analysis, if you say produces error, give me 1. Multiple of you said Invalid token. Give me an example. Huh? If I write, ayyo, if I write at the rate, right? In C, it's a invalid token. Correct? This can give me a lexical error. Any other example? As I said at the beginning, I want each one of you to speak. Huh? Backtick character, backtick, okay. Not the forward tick character, forward tick. You are saying backtick. That's a lexical error, right? Okay, sounds good. So you can think of more tokens, which are each one of you go back and find out what other lexical errors are possible. Okay, I'll be giving many such questions to you. Write down, and when you go back to your rooms, spend some time finding answers for it. Okay, we also said backend can give errors. Give an example of a backend error. What does the backend do? Optimizations, code generation, and so on, right? Now, what error can be there for in a backend? Sorry? I want very specific errors. I mean, hardware related, backend related. Be more specific. Again, be convinced. Accessing a, why is that a compilation error? In C, for example. So he's saying, let's say I have some pointer. Is it visible or is it too low? Guys in the corner? Is it visible? Okay. Char star C equal to null, and I'm accessing star C, right? Either writing or reading. Why is it a compilation time error? That's a runtime error. May throw a runtime error. Why did I say may throw a runtime error? Illappa, let's say you execute star C. C is pointing to null, right? But I'm saying it may not even throw an error at runtime. No, see the point. What do you mean by undefined error? Not the compiler. I'm saying you're executing a code which is dereferencing null. You're loading from the address called null, right? Is there a guarantee that it will throw an error? Okay, some value that I don't understand is a separate issue. My question is, since I have not written it, I don't know what is there, but what I'm saying, if I load from address 0 or address 1, address 2, whatever, right? Is there a guarantee that it will throw an error? All right. How many of you say it will throw an error? Accessing null pointer. The star C, right? Raise your hands. Let's see. How many of you say it will not, definitely it will not throw an error? It will never throw an error? Okay, how many of you say it may throw an error? You are saying may and both, huh? Okay. On all your machines, if you try this, it will throw an error. But why am I saying there may be some scenarios where it won't throw an error? All right, you are going in the right direction. So I'm saying I'm loading from address 0, right? Currently, why you get an error? Because you don't have permission to access it. That area is protected. Let's say you're working on a system where there is no protection memory, no memory is protected. You're accessing memory, so you're accessing memory, no error. For your C programs, it will, on your machines, it will be, it'll, not just architecture, yeah, OS architecture, it's a mix, right? But for our purpose, we'll assume that that can be 0, but that's not a typical backend error. So give me an example of an error which is thrown by the backend. Is a program with a lot of global variables? What's your name? Arnav. So Arnav says, if the program has a lot of global variables, then see, the compiler may say, look, the amount of memory I can allocate for globals is blah, some limit. Or the amount of the maximum size of a function that I can deal with is blah. So there are some such restrictions are there. In such cases, it can be a backend error. Here are some more interesting things. Let's say you are designing an app to be run on a sensor, which has to be deployed in some remote areas. The sensors have very small amount of memory, correct? Let's say the code you are emitting will not fit on the sensor. You won't know it in the front end, but in the back end you will be able to say, oh, this won't fit in, right? Those can be back-end errors. There are other examples. Let's say in C you have this assembly. Do you know this ASM directive in C? Using ASM directive, you can actually inline assembly code. It is treated as plain string by the front end, but the back end knows whether it's valid assembly code or not. What if backend finds that that code is not valid assembly? That will also be a backend error, right? There are actually many such small things that happen. Yeah? Yeah, correct. If it's some invalid code you have given, right? The front end doesn't know how many registers you have, what are the register numbers, what are the actual all the instructions available and all that. Okay. Your name again? So Jayashree is asking, let us say, in the backend we have many optimizations, right? Let's say one of the optimizations doesn't do what it is expected to do. What do you mean by doesn't do what it's expected to do? So now you are saying, what if the optimization has a bug and it does incorrect, it does a translation which is not semantics preserving. That is, originally let us say it was sorting ascending, because of some optimization it became sorting descending, some such thing. It so turns out it's not easy to figure out whether the optimization is doing the right thing or not. Most of the compilers do not do this checking. There are some efforts in this. Okay, look at this thing called comp cert, COMP comp, CERT cert. There is a project you will find which does certified compilation. Okay, that means every step is certified that it's correct. For every pass. right? But we won't go into concept, don't worry, just it's for your own self-study. Anyway, coming back to it, in general, identifying whether the optimization is doing the right optimization, in the sense the generated code is doing the same thing what it should be doing, or matching the semantics of the input code. The word semantic means what? Semantics means no grammar, Baba. Meaning. The word semantics is meaning. So when I say semantics should match what the input program was doing, the generated program should be doing the same thing. Okay. Let's say the input program, we will be mostly, let us say, talking about how the effect of the input program. Let's say it's printing something. The generated program should print the same thing. If the input program is doing some computation, the generated program should do the same computation, should get the same values, right? Now, see, let's say you are multiplying by 2, x equal to a times 2. He decides, no, I will do x equal to a plus a. Are they the same program? No. Are they computing the same value? Yes. Correct? So, we need to understand the word, what does the word semantic mean? Yeah. Any other points so far? Okay. So, we work in this setup where the IR helps us separate this front end and back end, and we can do multiple different language front ends can map to the same IR, and from one IR, right, you can write different backends for different architectures, right? Typically, we have multiple passes. So if you look at the 7-phase compilers, right, we would have briefly looked at lexical and syntax analyzer, some time on semantic analysis. Some part has been already discussed about code generation and optimization, like low-level optimizations and so on. Today, what we'll be looking at is high-level optimizations. Loop optimizations. See, loop optimization means I know that there is a loop exists. In the assembly, do you see a loop? I mean, it's just a sequence of low level. But at a higher level, I can see it's a loop. Oh, it's a for loop, it's a while loop, right? So typically, loop optimizations require us to have the high level information. It's a loop, it starts here, the cycle is here, things like that. Yeah? So our target is only one out of the 7 phases. It's mostly machine independent optimizations. Okay? Most of the loop optimizations we are talking about are machine independent. Some of it could be towards the end we will do. Okay? Like Professor Uday said, even though it shows as a 7-phase compiler, the number of passes in a compiler you have in hundreds, many, and they are growing. Right? So each of these can have many small passes within. Correct? Okay. Our goal is to look at optimization. Okay? We want to generate fast code, let's say. Okay? What do we mean by optimality? Is it the most optimum code? What is the difference between optimum? What does optimum mean? What does optimum mean? The best ever possible, right? Irrespective of the inputs and everything, right? We are not aiming for optimum. That's too difficult. Many of the problems we are talking about are difficult. Some are undecidable, to get optimum code. Okay, we are happy that if the optimization improves slightly. Okay, we should be aware that not all optimizations are friendly to each other. Maybe you two together will improve the code, but maybe between him and him, if both are applied, maybe they don't go well together. They are not as effective they are together. Though such things also happen. Because the optimizations can also be having overlapping effect. Okay. So then how do we choose which optimizations to pick? These are some of the questions we'll explore. Okay. Again, we are saying an optimization is something that is expected to improve the code. Okay. But remember, we are saying improved code. We are not saying optimal or optimum. So it turns out it's undecidable. I'm using undecidable in the CS theory sense. It's undecidable to, in many cases, to say, oh, this optimization will definitely improve. So here is a fun question to think about. Let us say I have a simple transformation like algebraic simplification. What is an algebraic simplification? Let us say I have x equal to x times 2. Okay? I replace it with x equal to x left shift 1. Let's say x is an integer. Both are same. Multiplying by 2 same as shifting by left. And you know that typically the left shift is faster than multiplication, typically. But why is there a chance that that can give me bad performance, poor performance? Correct. So it should, if it is faster, it should give me better performance, isn't it? The question is, why I am saying that, oh, there is no guarantee. There is no guarantee that there is no guarantee. We cannot give 100% guarantee, is what my point is. Possible? See, there are a lot of other factors at play. Like you said, at an architecture level, you may have multiple units which are playing. Maybe the multiplication unit is free at this time, and you could have used multiplication, but the addition or the shift, the other ALU unit is not free. Or what is its effect on instruction scheduling? I'll give an example. I'll actually, while you think about it, I'll give you a much more an example that all of you will say, no way. Let's see if I have the example here. Let's say I have some example like this. I have a for loop, and I'm computing C equal to A times B. Okay. A equal to, no, let's say I'm not changing A, D equal to blah, E equal to C. Yeah, I have code like this: D equal to blah, D equal to something, C equal to A times B, and E equal to C. C plus D or whatever. Some computation is going on. Is this code clear? Not visible? Oh, now you will be in trouble if I turn it too much. Okay. So now let us say I transform this code. See, if you look at it, the value of A and B are not changing in the loop, let's say. Then I can change it to C equal to A times B, the same for loop, D equal to blah. No, I will change slightly. Wait. There is some use of D here, and let's say E equal to C plus 1. I'll keep it C plus 1. There is some use of D, some computation of D and use of D. Okay? And here the same thing, same computation of D, use of D, use of D, and then I have E equal to C plus 1. And there is a print E. Okay? So far so good. So here I am computing this many times. Yes? Here I am doing this only once. Which is faster? Doing it one looks like the better thing, no? There can be cases where the right side will give you bad code. I mean worse code, not bad, less performant code. If anyone can tell me why, tomorrow when I come, I should have got it today, tomorrow when I come, I'll give you a chocolate. Not a very hi-fi chocolate. Chocolate is symbolic. Huh? There are some chocolates here. Yeah, it's okay. So let them answer, we'll get the chocolates. Thank you. Yeah. No, but I may be, this may still be in cache, no? If you are saying cache is the question, then cache may still be available here. क्यों नहीं? I mean, if C is available in cache, it can be available in cache here as well. Yeah. No, let's say for loop is true. Yeah, here's an interesting point that it's not equivalent. What he's saying, this is not equivalent because this is computed all the time, right? So what I'll do, I'll just make it some 100 or 1000 or something, just to avoid that issue, because this otherwise the transformation is not correct. It's not equivalent. Yeah. So I'm saying that yes, loop will be taken. Yeah. Anyone else? I see some good smell for the chocolates. Aha, we have a Kopiko here. And who wants a Kopiko? Looks non-intuitive, isn't it? The right side which I should say is always better. But I'm saying, in general, yes, we will do that. But there can be a chance it will lead to poorer code or less efficient code. Why? Yeah. No, let's say A and B are not changing. That's only then it would be correct. We are saying it's an equivalent transformation. Okay, we will study more about such transformation. It's called as loop invariant code motion. A code which is not changing in the loop can be moved out. Okay. Okay. I have not heard any response so far from this group yet. I mean it when I say I want everyone to participate. No, no, let's say loop. I mean, no, there's no failing. I equal to 1 to 1000. So it will go inside. So what our friend is saying, oh, having this instruction here could be good for my pipelining. Possible, okay? Uh, there can be, you can construct a case where moving instructions out can lead to a some issues in software pipelining. Possible, okay? But so if you can get the exact scenario, you will get a chocolate for sure. You have earned nearly a chocolate, but yeah. But that's only once, no? Otherwise, the pipeline would be stuck here for much longer every time. So what she's saying is, let's say that computation that's moved out is big computation. Then I'm waiting for longer. But here you will wait for longer in every iteration, isn't it? Floating point instead. Okay, so what? No, no, whether it's whatever is the left side, if left side is floating point, right side also floating point. I'm not changing that information, right? मजा आ रहा है? Okay, I'll give you a hint. Okay, it's related to what Manas covered in last 2 days or last 2 to 3 days. Okay, what about it? It's related to register location. What about it? Give me concrete thing. I've given you a hint. It is increasing the live range of C. Look at this. In this code, C is live only from here to here. Right? Only at this instruction, C is live. As a result, C and D can reuse the same register. Here, C's live range is from here to here. They cannot reuse the you have earned a chocolate. Do you see this? It looks like a good transformation, which is happening way early. Register allocation happens very late. And because of that, the live range increased. Because of that, maybe you have to spill something. Because of that, you have to pay more cost for memory access. I will now do one thing. I'll take a quick break. I want you to understand that such things can happen. Okay? And this one I still have left. This you do for self-thinking. But for this example, please pair up as 2 or at most 3s. In this case, I mean, since there are times when you won't be able to fill as 2s, group as 2s or 3s at most, and then convince your neighbor that your neighbor has understood. Okay? So I will be asking whether your neighbor has understood, not you have understood. So talk to your neighbor or neighbors, come nearby. I mean, yeah, so you can talk now. It's okay. So here noise is good. I don't know. So there will be a lot of registers. So here, what's your name? Huh? Lukman. So Lukman is saying, is it the case only when I don't have sufficient registers? I don't know how many. See, the registers are always finite. There may be a scenario that I had to spill because I moved the code out, because the live ranges have changed. Okay. Yeah, please continue discussion. I'll give you 2 minutes. Convince yourself and your neighbor that both of you or three of you as a team have understood. Yes. Yes. Correct. Absolutely. There are many such interdependent passes. See, you would be, see, yesterday Arun would have told you that instruction scheduling and register allocation, they interact with each other. You would say, okay, fine. You wouldn't be so surprised because they are nearby passes. Both are low level optimizations, right? Both require us to know the hardware details. Here, this looks like kind of so disconnected to the hardware, right? But it can still affect a later pass. Please continue. Excellent point. So our friend is saying, so what if I have to spill? Maybe it is faster to, let's say the multiplication, like she said, is something that's is taking, it's a big integer thing. It takes lot of time on my hardware. Multiplication takes lot of time. It's better to move it out. Even if it requires more spilling, it may be okay. Who knows? Maybe it's okay, right? And that makes this problem more interesting, right? We have to take many things into account when we are making a decision. You're absolutely right. What's your name? Dhruva. So what Dhruva is saying is, it's maybe the multiplication is so expensive that doing it inside is not worth it. Maybe it's worth paying the cost of an extra spill if required and move it out. Who knows? Maybe it is. Right? Good point. Yes, it is. So, see, let's understand there is a trade off. You are computing it once, you are computing many times. Reduced computation versus possible spilling. How much will you save because of reduced computation? How much cost you may have to pay because of increased spilling? Let's say you are an oracle who can see through things. Then you will say, aha, this is cost 10 units of time. This will save me 10 units of time. This will save me 8 units of time. So saving 10 units is better. Right? Is there any other way we can decide? We have to see what is the impact of X, what is the impact of Y. Maybe that register, see, your register allocation is also a heuristic only. And you decided to keep C in register and D in memory. And D is used many times. As a result, you are spilling, you are kind of loading and storing many times here. It's a cost. See, when you say it's one register, it's not just one register. Correct. So memory, see the memory, if I spill, I pay more cost. Cost as in takes more time, isn't it? When I spill something, I'm paying cost. What's the cost? It has to load and store from memory. Correct. If I if I keep it inside the loop, I'm executing it many times. Right. So it's a standard thing that if you become teachers, you will see this. Students will say, we want to take a break. Let's skip the class today. The teacher will think, aha, if I skip the class today, the students will come back tomorrow with a happier mood, right? But if I skip the class today, I may not be able to complete my portion. I have to hurry somewhere else. You have to see a trade-off. The same thing as students you will be doing. My friend is calling me for a movie. If I go to the movie, I'll have fun, but I will be losing some marks in tomorrow's quiz. Then you may say, hey, I have enough marks from the rest of the quizzes and assignments. Even if I lose a couple of marks, it's okay. Let me go for a movie. So these trade-offs are common, right? The critical thing here, Ma, is finding, what's your name? Jayashree. The critical point here, Jayashree, is the compiler has to somehow quantify and make a decision this way or that way. We'll see some of it, it's not easy. Because I don't even know the input. It's a very difficult problem, like identifying the right sequence of optimizations, identifying which ones, because it's not one or two, there are many. There are many. Correct. There can be an issue with the network's point of view. Yes. Let's say you are writing a network processor. Some network packets are coming at a certain rate. What is the impact of it in processing the packets? It is fuzzy, right? Because what we are saying is when when you are having uh, a program, let's say I have a program which is running, but for the program to run, there are many other actors around it. Architecture is an actor, right? The underlying architecture. The underlying OS is an actor. The network packets that may be coming. If let's say this program is a packet processing program, then it may get impacted by how the packets are coming. I may have to know a bit about network packet processing. It could be a combination of all. Yes. So you may think, hey, this is too crazy, right? With so many combination, so-called hidden things. The more you unravel, the more you will be able to understand and appreciate. It is hard. And so that's the best part, right? These problems are so hard, and with advances in every other thing, right? We will also have to keep making progress. So that means if you are working in compilers for your lifelong, you will have amazing problems to solve. You will have a job for sure. Tomorrow X is hot, day after Y is hot. But if you like compilers, you will always have beautiful problems to solve. Okay. Anyway, let's continue. So the goal of optimization, we so far were talking about speed. And we said, oh, one optimization can improve speed. Oh, but it can also impact the speed negatively. If you think that is complicated, let me add a few more. Let us say you are generating writing an application to run on the pacemaker, to be put on the heart, right? You know, these are small machines. They don't have lot of space. So you ideally want to make sure that the generated code takes less space. Correct? It so turns out if you want to optimize the code for speed, sometimes it may increase space. So do you want to optimize for speed or optimize for space? And then sometimes you want to optimize it for power. Let's say your cell phone apps or my watch app, right? You want it to run fast, but also it shouldn't consume too much battery, right? Ideally, we want it to run fastest, take least space, take least power, right? These things are not always friends. They may be conflicts. Which one then matters? Depending on maybe application, I would change it to depending on the need. The same application may be running on your small device and maybe running on your server. On the server, you don't care maybe for, let's say it's sorting. Sorting is such a common thing, right? You may be sorting on on a server, sorting on a cell phone, sorting on a small device. All are possible. You would probably want something which is very power efficient in one, very fast in the other, right? So it depends on the target. Depends on the target machine, target requirement. Traditionally, when we say optimization, we optimize for speed. Okay. Sometimes optimizing one, improving one, improves the other. Not always. Right? It's like this. Sometimes eating food is also healthy. It's good for tasty for tongue and also healthy. But there are times when it's tasty for tongue but not healthy. Right? Correct? Okay. We will see some examples. Remind me of this. Okay. Even though we keep saying optimizations, not all optimizations are same. Some optimizations are more important than the other. You heard this one? All animals are created equal, but some are more equal than the others. No? Read this book called Animal Farm. Okay. So, the optimizations, if some are more important, right? Which are those? Let's fix our target as speed. So, which optimizations will give us more speed? Naturally, if in the code where you are spending maximum time, if you can optimize that part, it's good. In the code, typically you spend maximum of your time inside loops. Right? Recall your complexity calculations. You have a sequence of instructions, you just say plus 1, 1, 1, 1, 1. When you see a loop, you multiply by n. Right? So the loops are the ones that not only theoretically determine the kind of theoretically dominate the complexity expression, in practice also they are most critical. If you can speed up loops, your programs are most likely going to be fast. Registers and memory, right? If you can do efficient register allocation, that's going to impact throughout your program, inside loop, outside loop, everywhere. Correct? Same thing with instruction scheduling. These are very important for performance. The others are also important. I'm not saying they are not. But if you look at some of these, their impact is very high. Okay? Sorry? No. I can always write a program where something else is more important. By the choice of programs, choice of optimization may also depend on the input program. For example, for object-oriented programs, function inlining is very important. What is function inlining? Does anyone know? Yeah. Excellent. When I have a function call, so this whiteboard is very similar to the whiteboard in my office. I keep telling my students, if you keep using my whiteboard, you will have build lot of muscles. Okay, so let's say I have a call to function foo somewhere, and the body of foo is here. Function inlining, what it does, it removes this and replaces this with the body with appropriate renaming and all that. This is called as function inlining. Okay? Function inlining. What's the advantage of inlining, can someone say? Someone from either this 6 or those 4. I'm just looking at row wise. There's been no questions answered by these 2 rows and this. So only you 3. Reduce context switching. So what's context switching here? Guys, this is not a neighbor's time yet. Please listen to our friends. Yeah. So what is context switching in your mind? Okay. So what's your name, ma? Sridarshini says when you have a function call, you have to actually make a call. You have to jump. There is a jump instruction, copy the arguments, jump, do something and come back. Right? In register location, you would have seen, you would save the context, calling context, you'll save the registers, do something, come back. That's all additional overhead. If I inline the function, I'm saving all that. Right? By the way, inlining is an example where it is faster but increases the code size. Because that function foo is called at 2 places, now you will have body copied twice or n times if there are n calls. So it's, do you want faster code or smaller code? Okay, let's come back to, in OO programs, I'm claiming inlining is very important compared to others. Can you tell me why? Again, you'll get a chocolate for this. But why is function inlining more important for object oriented? What you're saying is function calls are expensive. Function calls are expensive. So inlining is better. I agree with that. But you still have to dereference even if it's you inline it, right? Because the dot f there and dot f here, you still have to do it. Which address? No. Those I may have, maybe let's say I have something like this, right? A equal to new, and I'm passing A here. So if I have an access A dot F here in Java or in C++ or C, you have A arrow F, right? Here also you still have to do the same thing, A dot F or A arrow F. So that dereference will still be there. That's not reducing. So why is inlining more important for object-oriented languages? Inlining always enables many other optimizations, but irrespective of whether object-oriented or not. The question is, I want to kind of tell you that, look, the optimization that you invoke can even be because of the language that you are working on. Yes, so now that team has gotten one answer. Now these two teams have not. Think. Okay, there are a lot of methods that can be called. Same thing in C also, I can call a lot of methods. Correct, but that's true for C also, right? I can have a lot of functions, and those functions, think. It's a chocolate question. Absolutely. Every time you do a function inlining, it reduces the method call overhead. That's what Sri Darshini said, right? Which is all of us agree. Now the question is, why is it more important for, very important? True. So if you inline, you will save there are a lot of advantages. All of us are trying to say the advantages of inlining. I am saying, why is it more advantageous for O, or more required, more essential for O language? Okay, uh, last attempt. Why? Can you elaborate? Hmm. See, object-oriented programs. Let's say you're familiar with C++ or Java. All of you. You have this notion of private fields, public fields. If you have private or a protected field, how do you typically access it? Using typically getters or setters, right? Think about it. Like Sridarshini said, to make a call, you have to save a bunch of things, do a jump, do that code and come back, and again restore everything. So much work for reading one field. No. Such functions, it's a function overhead, absolutely. Such functions are extremely common in OO programs. In C, you rarely write a function that will simply read a field. In OO programs, it's very common to have these getters, setters, these small, tiny functions. It's very common in OO programs. Hence, see, it's a question, right? When you make a function call, there's an overhead, absolutely. If I'm doing some work here, right? If I'm doing some work, okay, I made a call, I do some work and then come back. But if the work is very small, right? If I inline, I probably it won't increase the code size. Let's say it's a getter. Many times, exactly. Compared to a language like C, all field accesses are going through getters or setters. If I inline all the getters, if I inline all the setters, what's the advantage? I'm avoiding function calls, and mostly my code size is not increasing by much, right? So at an assembly level, my dear, there is no private or protected fields. The private and protected are just what I call as, yeah, just to make the programmer happy. At a lower level, there is nothing called private or protected fields, right? Everything is memory. Okay. Similarly, if you have a code which has a lot of recursion, tail call optimization. Basically, tail call optimization is an optimization where instead of calling the last function, let's say you have a function after which you don't do anything else, don't call, jump. Okay, that's called as tail call optimization. Read it yourself. Okay. There are times when it's advantageous to replace a recursive function with a loop. What advantage can I have? We know that recursion and loops are equivalent. What you can do with loops, you can do with recursion and vice versa. We agree with that, right? But I'm saying replacing recursion with loops can be advantageous. What can there be? Correct. when you have a recursive call, a deep recursive call, you're taking a lot of stack space. You turn it to a loop, I'm avoiding that overhead. So horses for courses. Okay, depending on my requirement, I may say, oh, for these type of languages, these type of optimizations are better. Correct? Okay. Types of optimizations, there can be local within basic block, intra-procedural within a function, inter-procedural across functions. Okay. Similarly, the optimizations could be high level, which are not dependent on the hardware. They depend on the program structure, or low level, which work on, say, registers, which needs information about the hardware, things like that. Okay. So the optimizations can be machine dependent or independent. Machine independent ones are, same optimization is likely to give you better results for across different machines. Okay. For example, moving some code outside the loop, this would be machine independent. Okay. Removing dead code, machine independent. Machine dependent are those optimizations which take advantage of machine properties. Register allocation is a machine dependent optimization. Instruction scheduling is machine dependent optimization. Okay. Okay. As we said, desirably an optimization should be such that it gives the best code. It should give me excellent performance. It should give me predictable performance. It's not that randomly it gives me good performance. It should take advantage of all the high level features and optimize. It should take advantage of all the architectural powers, architectural specialities. It should, the optimization should support many different language features. It should compile very fast and give me the best code. In practice, it doesn't happen. I mean, these are all ideal goals. We will try to meet as much as possible. Right? Okay. But one thing which is non-negotiable is that the optimization should generate semantically equivalent code to the input. People will excuse you if you say, okay, oh, it's not the fastest. But is it generating the equivalent code? If it is not generating an equivalent code, then nature, most of the time. There are times when they say it's okay if it is not generating the same output. Can you give an example? It's okay if it's not giving the same output. The question is, in general, we want the optimization should generate the code such that the input and output have the same output. I mean, the original code and the generated code should have the same output. But I'm saying there are times when they say it's okay if it is not exactly same. 80% same, 90% same. Chalega. No, I'm saying with optimization, I'm saying sometimes I'm saying it's okay to have a slightly different output. Right. So when is it okay to accept an approximation? Okay, what about them? Yeah, but the compiler probably, yeah, that's a good example where, let's say, because of the compiler optimization, some the classification hit rate, right? Or the regression percentage has slightly changed. There is some more thing that many of you would appreciate. No? Let's say you are rendering a video. To make it fast, you pixelate it slightly more, right? Chalega, you could still see that Dhoni hit a 6 on the last ball, right? It's not full HD quality, but you could still enjoy your life, right? There are times when you have, let's say you have floating point operation, like I guess that's what you're referring to. There are some times when you are saying, okay, it's okay if I don't get full precision. There are just few computations. I can tolerate some amount of loss of precision. It depends on the application also. Right? Okay. All right. So the moral of the story so far, we are saying there are 3 considerations when you are applying any transformation. It should be safe. I would like to see that it's profitable, right? First is safety. Second is it should be ideally profitable. Third is, how do I know when to apply this optimization? Because you are given a big program. I want to find where is the opportunity to apply this optimization. Okay, we need a clear understanding of these things: safety, profitability, and opportunity. Okay. Safety, non-negotiable. If you are saying that, hey, this can be done safely, only then do it, else don't. We are not talking about those cases where we can tolerate some loss of precision, but yeah. So, sometimes reasoning about safety to do this transformation, is it safe? Sometimes it's easy, sometimes it requires lot of detailed analysis. Okay. There are some optimizations which are always safe. Some are not. Some require reasoning. Profitability, there are ways to estimate the profits, like you said, no? How do I know? Can I quantify how much the impact? So we do have some heuristics to quantify the profits. If we believe that yes, it is mostly profitable, do it. There are also thresholds. Actually, you talked about threshold, no? We said if you inline a function, it increases code size. I can keep a threshold. Hey, if the code size increases beyond X% or Y bytes, I will not do it. Rather, what you're saying is a threshold should be computed with some insights into why the threshold is right. So there are in compilers, what you will see is that the compiler writers, after studying lot of big benchmarks, they say this threshold is good for this optimization, that threshold is good for that optimization. Different compilers sometimes even hard code these numbers because they feel for their compiler this threshold is good. It can be on paper, it could be. Many times for unrolling, inlining, etc., they keep a fixed number based on realities of life. Okay. And opportunity. How do we identify, yes, so and so can be optimized? Let us say you have an amazing optimization. But to identify this particular, how to apply this optimization, where to apply on your program, it takes lot of time. It takes 10 days, 100 days, I don't know. Unacceptable amount of time. Nahi chalega. Mudiyadu. Right? So what we have to do, we need a way to identify these opportunities, ideally fast. It shouldn't take too much time. Right? Okay. We want to ideally find where all we can apply a transformation. quickly. We want to see that the transformation can be applied safely, and at that location, if I apply the transformation, it should give me good performance. At least likely to give me good performance. Okay. Now, again, I'll come back to your point. How do I quantify? I have a piece of code. If I apply a transformation, let's say it is saving 2 cycles. What if that code is inside a loop? How much am I saving? Number of every time the loop executes, I am saving that. Isn't it? So, the profit is local improvement times the number of times it's executed. Let us say you have one piece of code here, one piece of code here. There is some optimization that says if you optimize this one, you cannot optimize this. If you can either save 10 seconds here or 4 seconds here. Either save 10 seconds here or 4 seconds here. Which one will you optimize? Okay, what our friend is saying is, let's say we don't make the decision yet, we'll run the code. If we run the code, what will we get? We can get trace of the program and say, hey, this part is executed 100 times. That part is executed 500 times. Oh, it's 100 into saving 10 cycles. That is 500 into saving 4 cycles. Where I am saving more. But my friend, now if you say I ran the program, but next time the input is different. Maybe next time this one ran more and that one ran less times. Can we find all the possible sets of inputs? So what people will do, they'll say, look, I won't be able to get all the inputs, give up. Whatever I have come up with is also not guaranteed to be applicable all the time. It's a heuristic. I will do one of the following. Let's say I ran the program. I call it as profiling. I profile the I run a profile run for some small input and get in, oh, this seems like executed more frequently than that. And generate code. It won't be, there's no guarantee that it is perfect. No guarantee that this is perfect, but one hope. Here is one more hope. I will not run the code. I will not run the code. Here is a piece of code which is inside a loop. I'll assume every loop execute 10 times. Here is a loop which is a code which is inside a nested loop. 10 into 10, 100 times. I'll give this more priority than this. Heuristics. As an intuition or an assumption. Pay attention, we are not compromising on the correctness or the safety part. We are only saying, hey, I have a choice between optimizing this way or that way. Which one should I pick? Correct? I want us to be convinced that we are not saying we'll get the best option. It is a heuristic to choose this or that. Okay? We'll start with loop optimizations discussions. Why loop optimizations? Because they are going to be most effective. In programs, if I can impact loops, I can impact the performance the max. Okay? Yeah. Absolutely. So static compilers will end up taking some assumptions, making some assumptions and then saying, here I think this part of the code is likely to be executed more. Right? Maybe this branch is taken, this branch is mostly likely to be taken. This branch is mostly likely to be false. For example, let's say I have a while loop. While loop checks, most of the time what happens in a while loop, the branch is, the condition is true or false? True. Even though there is no guarantee, as a compiler, I'll say, you know what, in a while loop, I will assume the branch is true. The condition is true, correct? I have a code that looks like this: if condition some statement, else throw an exception. Which one do you think is likely to be taken? The then branch or the else branch? The one throwing exception, the one doing some computation. Is there a guarantee? No. So even without running the code, we can have such assumptions. Let's say I have a condition that checks and returns else a recursive call. Which one is likely to be taken? The recursive call, because I mean, that's the looping part, right? Again, these are all heuristics. कोई guarantee नहीं है, right? Yeah. Questions? Oh, yeah. You will have, for every pass, you will have heuristics. Sometimes these heuristics may be written by many different people. They may have contradicting views. सब होता है. I mean, they may be contradicting with each other. Well, in theory, possible. In practice, within the same pass, it doesn't happen as badly, because same pass may be, I mean, whoever is writing that pass will probably have an idea of what's happening in the pass. But in industry, you wrote the code today, you left, you got a very high-paying job. They called me for your low paying job, and I'm bored. I'll end up writing a bad code. Possible. But in general, it's not so bad. Within a pass, there is more consistency. Across passes, there is more inconsistency. Yes, then that part. Absolutely. Right. Time complexity doesn't change, my friend. Most of the optimizations do not change the time complexity. Most, I'll tell you why most, but most of the time we are not changing the time complexity. Time complexity remains the same. Just that you will say, see, in instructions and architecture, when you jump, you can give the hint to the architecture. You can assume it's taken or not taken. What is likely to be? It's a take. So the architecture has to guess, right? Because when you have a branch instruction, where should it fetch the next instructions from? It's a conditional branch. Should I take it from that target or this target? Which should I take the instructions from? Correct. How did the hardware do? Correct. How did the hardware predict the branches? But first time, what does it do? No. The compiler tells. It can do. The hardware can. If you don't tell hardware, it will do what it has to do. The compiler can pass the hints. It's a likely to be taken branch. You will be amazed at how much interaction can happen between architecture and compilers. Anyways, let's talk about one example. It's called loop unrolling. Okay? What is loop unrolling? The idea is, see, in a loop, like in a function call, Sridarshini. Like Sridarshini said, for a function call, there is an overhead. For a loop also, there is an overhead. Do you know what's the overhead? At the end of the branch, I have to jump. So there is, after every iteration, I'm jumping. After every iteration, I'm incrementing the loop counter. Correct? So what if, let's say I have a loop that says iterate over this body S. What if I just unroll the loop? I say in every iteration do 2 instances of S. Let's see. Yeah. Let's say I have a loop like this. Uh, I goes from 0, I less than 100, I plus plus. I increment I once. The body is unrolled. I mean the loop is unrolled by a factor of 4. How many branches are here? How many times will I branch back? 100 times. Correct? And last time I'll go out. So total 101 branches. Here how many branches? 25 plus 1. You'd say, if you remember from your instruction scheduling class, lesser the branches, better pipelining. Here I have removed the branches so faster. I'm executing fewer instructions, right? I'm also not incrementing I every time. You can say, hey, I'm doing addition. Okay, thoda that will get, there will be some thing there. But yeah, so loop unrolling, if you see, this is a very safe optimization. It's always safe. You don't need to check any condition. Goes wrong as in may lead to, what did I say? Safe. It's always safe. Did I say it's always profitable? No. It reduces overhead. There can be an instruction blowout. There can be, it increases my code size. I don't know its impact on register allocation. Absolutely. So the point is, maybe I'll have some heuristic that says it's okay if I'm unrolling it so that the number of instructions increase by 48 bytes. Safety, yeah. Safety is, let's say, for our case, is non-negotiable. Correctness is important. So unrolling, if you do, it's always correct, safe. Identifying opportunity, trivial. Just go over all the loops. Go over all the loops, unroll. Correct? Easy? Okay. What if, let us say I have some code like this, exactly for you. I goes from 0 to n is some user input. This. How do I unroll it by, let's say, factor of 4? No, forget cache and everything. We are not talking about profitability. Let us first think of safety. So profitable, typically loop unrolling is profitable if the bodies are small. Okay? So for the time being, let us say we are thinking that it is profitable because the body is small. My question is, I don't know the value of n. So let's do one thing. We won't do any of these things right away. Look at this code. Check with your friend. Each one of you come up with a transformation. Unroll the loop. I want the factor of, I want the loop to be unrolled by a factor of k. For any k, I won't even tell you 2 or 3 or 4. For any k, unroll. The only thing you know in this code is I is starting from 0 going till n. You don't know the value of n. You also know that I is increasing by 1. The body is any s. Don't bother about this. Just say some statement s. Okay? Go ahead. Again, pair up. Rahul, please go around. Check if students are, what they are doing. If they have any questions, let's listen. Right? And let me give you a incentive for completing this fast. I believe the break time is up, so you can have tea or coffee, something. So earlier you fast, faster we go. Right, madam? 10. Ready, na? Good. So இப்போ 10:30 ஆயிடுச்சு. Maybe இன்னொரு 5 நிமிஷம். So we are talking to our neighbors, no? All of us. Do we know our neighbors' names? All of you, do you know your neighbors' names? If not, it's a good time to find out. Attendance done. Everyone has signed the attendance sheet? Anyone who has not signed? Thank you. Discuss and come up with one solution, not 3 solutions. I don't see anything written. Okay. Thinking. Okay. Hmm? No, it will, yeah, exactly. It will branch n times. If I unroll it by a factor of k, I'll reduce the number of branches. See, if you look at it, I'll go back to the previous one. In the original code, if you look at it, there are 100 branches, right? Second one will be here 25 plus 1. So here I have n branches. I want to see if I can reduce the by a factor of, there I reduce by a factor of 4. I want to reduce by a factor of k. No, k is, let's say, given, but some k. So I want you to write code, unroll it. But this is n there because, okay, I guess we should pay attention. Here I knew the value of k to be 4. What does it mean? Since it's only 4, I know that 100 is divisible by 4. Right? If I don't know if 100 is divisible by 4, what should I do? That's the reason why in this code, I don't know the value of n. I don't know the value of k. K may not be divisible by, sorry, n may not be divisible by k. What to do? Understood? Yeah. You have an answer? All right, we have a group which claims to have an answer. Where is the loop? No, write the full loop. Write the full loop. I want the transformed code. Yeah. You have an answer? I said k, that's why. I didn't want 2 also. I know for 2 you will do something. That's why I said k. You're thinking in the right lines, but think for k. You're thinking in the right lines. I'm just saying what you've written. Discussing. Okay. Good. Continue. This part is correct. This. What is J? What is J? The you nearly have the right answer, but not exactly. There is a minor mistake. So minor, it can be fixed with a couple of strokes of your pen. Yes, guys. Any hope? Why? Why not? I see you have written a couple of right things here. This is correct. This looks good. Do it. Correct. Do it. Put some additional code. It will not equal 0. What will you do? Correct. So you have one unrolled loop. See, guys, there are two parts, right? N, whatever the n is, there are two possibilities. It's a factor of k. It's not a factor of k. Sorry, it's a multiple of k or it's not a multiple of k. If it is not a multiple of k, what does it mean? There is some multiple of k plus some iterations. So let's execute the first part, the multiples of k in as an unrolled loop, the remaining a separate loop, right? Did you figure it out? Nah. Okay, so the idea is super simple. Let's see if I can. Oh, why am I doing this? I can do better than this. Uh, okay, so I have this code. This is my slide for that, right? I could have taken my friend's tab and do it, but here is my code. So what I'll do, I'll read the input as before. All of you can see this code, or is it too small font? Increase the font slightly. Better? Okay. So what I'll do, I equal to 0, I less than n by k. This is integer division. This is integer division, and then I will, what will I do? I'll repeat this code whatever the k times. Why did I do this? Okay, so k times I have repeated with I plus 1. So I could do, after the first one, I could do I plus plus. अरे यार सेमीकोलन कहाँ गया? Okay, I don't know, either you write here as I plus 1, I plus 2, I plus 3, or this, right? So this is done. What's your group's, what's your name? Rukmal. Yeah, Yalini. Yalini, Aishwarya and Rukmal had gotten this part correct, and many of you have also gotten this part correct. What do we do for the remaining? When I reach the end of the loop, what is the value of I? Huh? Some I which is a multiple of k. The largest multiple of k which is less than n. Correct? You know what I'll do? I'll remove the int here. I'll make it int I here first. Okay? And then I will cheat. Then I will cheat. I'll just copy this code. Done. See, at this time, value of I is a multiple of k. Could be n. It's not guaranteed to be less than n. It could be equal to n also. But it's a multiple of k, largest multiple of k, so that it is less than equal to n. So I'll just copy, I won't initialize I again. Aishwarya, yeah. That will be happening here, no? Yeah, so you first update and then check the condition. Correct. So let us say this n is 1000, k is 4. What will happen when I'm done? I equal to 1000. So I'll check I less than 1000. No, don't go inside. Again, do one thing. The same neighbors, please check and convince yourself this is indeed unrolling. Neighbors time, neighbors time. Why in that row there is a group of 4? Make it 2 each. 2 each. Fine? All those can be handled. We are talking about cases where there are no breaks. With breaks can be handled. It's not too difficult. It so turns out, guys, this statement need not be this small statement. It could be any statement. This could be any statement S. This could be any statement. I'll mark it as S sub I. S that uses I. May not even use I don't care, but I just kept S sub I to say S, or rather I'll make it parenthesis, maybe that's better. Some S depending on I. Okay? And what I'm saying, I'll just repeat it with do. That's VI for you. This is VIM. Okay. So those of you who are using any editor like TextEdit or VS Code or Microsoft Word, right? They are not editors. They are just telling you that they are editors. If you want to know what an editor can be, use Vim or Emacs. Oh, so it's like this. Which religion is the best? Right? Which series is better? Right? Harry Potter or Dash. I'm such a fan of Harry Potter. I will not even utter the other names. You can do syntax highlighting. You can do all that. So here, since this is LaTeX, this is not highlighting the text. You can all syntax highlighting can be done. Huh. Which branch I'm working on as in? So you want the branch name at the bottom, you can add it. See, please understand, Vim or Emacs have so much power. Let's differentiate between editing and other information. Vim and Emacs, the way they work is the editing is what they have expertise in. For all others, you can keep on adding the plugin. They're beautiful plugins, right? It's a very modular design. I mean, look what I did just now, right? Do that in any editor of your choice. I can over the course, if I keep editing, I'll show you some more things that I enjoy. But anyway, I hope all of you understand how it works, right? So this can be wait. Yeah, just so that it's all SI. So we understood how loop unrolling works. It is always safe. It's always safe, and we can do it. Okay, we will take a break now. We'll continue the discussion. But let me take a quick poll. Am I going too slow? Am I going too fast? If you feel it's a good time to tell, because I have another case sessions remaining. Okay? Chalo, let's have some tea, coffee or something and we'll meet back. Those of you who have talked in the class, good job, keep it up. Those who have not, do. Okay? There's no question which is right or wrong. You don't think so? Okay.